Hey everybody, this is Larry. This is day 30th of the December Leetcode Daily Challenge. 2 more days till the end of the year. Let me know what you think, how you do. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's problem. Smallest integer divisible by k. What does that mean? Given a positive integer k, you have to find the length of the smallest positive integer n such that n is divisible by k and n only contains digit 1. Okay. Yeah, what is the bounds on k? Bounds is okay. So yeah, so I mean, I think the idea here, and this is a problem that done a long time ago, but yeah, the idea is that you're given a k. I don't want to talk about this because so the thing is that there is a lot of number theory in about this. I mean, not maybe a lot, but at least like if you're unfamiliar with it, it's kind of hard to kind of come about. The idea is that, and there are kind of a lot of places that you can draw from into how to think about this problem. For example, there is some thing where you know if you have some x and then you do some function f of x on it, you know, there is some cycle, so you will always get an answer eventually. And you can also, I mean, there is more kind of math and proofs around it, but the quickest one I think is the pigeonhole principle, right? Meaning that it is either not possible, meaning that for whatever reason everything repeats. And what I mean by that is that, you know, like this cannot happen here, but for example, you can imagine, or at least with this function, where you times it by 10 and add 1 to get an extra 1, right? But yeah, so either it's not possible because you have a loop, meaning that, okay, like x mod k is equal to some number, and then that same number repeats without ever going to 0, right? So either that or that you hit every possible number in the mod k, so that at most you're doing k loops. So that's basically the idea about it. And of course, the first thing I would say, even though I said a lot about it already, so maybe it's not the first, but one of the first I would say is that, of course, another way to phrase it is that you have some x mod k is equal to 0, right? Where x is of the form, I don't know how to express this, but like, you know, 1, 1, right? And of course, the easiest way to, and as we talked about, we can try the first k digits, if you will, of the form 1, 1, 1, 1, 1, 1, 1. And of course, you can do that with giving a mod. We just have to make sure that everything is mod 0, right? Because obviously, if you keep going, then it even tells you it will not fit in a 64-bit int. In Python, that's not technically an issue. But if you have a digit of, or if you have a number of 10 to the 5th digits, it does slow things down. So it might actually time limit exceeded. I'm not going to try it because it's not, you know, the point anyway. But even if it's technically correct, it might time out, right? Where in other languages, it may just, you know, overflow or underflow or something like that. So yeah. So then the idea is that, okay, let's try 1 digit, right? And then 2 digit, and then 3 digit, and so forth, right? And of course, we're trying to get the smallest, so there is the natural progression, meaning that you go from smallest to biggest. It's going to be fine. And then of course you can kind of see this very easily that you know, to add a digit, I guess there are 2 ways to kind of see it. One is to add it in the beginning, like add the digit to the left, or the other way is to add it to the right after multiplying by 10, right? Shift and add. And that's the technique that we're going to use today. And let's get started. So basically, let's just say we have digits is equal to, say, 1. The current number is 1. And then while current mod k is not 0, we shift and add, and then we mod it by k because because this is a property of modular math, which is that using these operations, just to kind of go over very quickly, like A times B mod K is equal to A mod K times B mod K, right? Something like that. And also, of course, the same for addition, right? So you can do this here. Let's just pretend I have a good parent over here, but yeah, something like that, right? So these are some properties that I don't know. I wouldn't say you have to memorize it, but it does come up a bit if you do competitive programming. For interviewing, maybe not as much, but still. So these are things that you just have to kind of learn, because these are identities for modular math. But yeah, and then of course increment by 1, and then at the very end you're pretty much done. We give it a test some cases, test a big case, which is 10 to the 5th. And yeah. Uh-oh. I would say one thing I did not test is whether there's a loop, and you could kind of test that in a bit. But yeah, and also I guess this can be just current is not greater than 0 because we already mod K here. But we do seems to have a issue. Maybe I have a typo somewhere, and I've been bad with typos lately. It's either that or I misread the problem. Okay. I guess technically I could go like this, but oh, okay. So there is a thing where that's not possible. Sorry, I was thinking of another function where that's always the case. But we did already talk about this what we said about pigeonhole. So we just have to test for this. That's not that bad. And the idea is that if you have already seen a state before, and you could consider or the numbers over. I want to break into equivalence classes, but I don't really think I'm going to go that deeply into that right now. But the idea is that like this function, or this function, maybe more specifically, this function, right? As we kind of talked about before, this function for every, like, for example, I don't know. For example, let's say this number is 2, right? And then, how do I want to explain this? Sorry, give me a second. My point is just that whatever this number is, let's say you have some x, let's say you have some a, and then f of a, this is equal to f of a, right? If later on we see a again, this is still going to be the same thing. So this is not going to change. So that means that if you have seen the same thing before, then you should be done, because you're basically done because you're going to keep on repeating forever, right? So that's basically the idea, and I should have known this actually. I wasn't paying attention. Sorry, friends, because I was focusing on the explanation a little bit. But yeah, and in this case, you could maybe use a set. That's something that I would do a lot. Another thing that you can do is just have a Boolean value of, like a Boolean array of length k, because you know that every number mod k is going to be less than k. I actually, for this one, I preferred a set. It really depends on the problem, but I think for this one, well, I would also say this is a Leetcode special in that I think in if I do things in like Code Forest or something where every test case is by itself, it doesn't really matter because you have the time for it, right? Where on Leetcode, which is a little bit awkward and a little bit meta, I worry that this would actually take too much time in the long run, just because this technically takes all of k no matter what, or lower bound of k, right? omega of k, and not just upper or not just a complexity of k. And saving time here and there kind of adds up, and that's kind of the thing. But yeah, and then scene.add current. Yeah. So then here we can write this, and then maybe we can write if current is equal to 0, we just return digits. Yeah. And then here we return -1. So then we kind of change the condition a little bit. While current not in scene. I guess technically then in this case we have to add this here. It's a little bit awkward because I think the do while loop is probably cleaner here, but in Python that's a little bit weird. Okay, I do have a mistake though. What did I do wrong? I guess I'm off by 1 because I add 1 to the digit beforehand. No, because that's kind of why I wrote this here, but I guess that's a little bit awkward. I guess this can only happen when k is equal to 1. So we can kind of remove that, I suppose. It's a little bit awkward because, like I said, it should be a do while loop. So there are going to be like weird cases where this is happening. But yeah, let's also play around with a little bit more than I'm just banging on the keyboard. Really, there's no significance to these numbers. Let's kind of see how that shakes out. Let's see, and it looks good. So let's give it a submit. This has probably been a long explanation than I intended, but yeah, we have a 639-day streak, and yeah, one more day till another year. I guess maybe not another year, but first full year of daily Leetcode videos. Let me know what you think. Yeah, like I said, this is going to take at most k times because of the pigeonhole principle. So this means that this will only be all of k space. But yeah, let me see what I did last year. I guess I pretty much did the same last year. Okay. I actually explained it. I talked about the relationship as well, I guess. But yeah, let me know what you think. And if today's explanation is not that great, check out last year's explanation maybe. I don't know, maybe that's better. I'm still in Panama, so my whatever, it's a little bit weird. All right, that's all I have. Do I look naked? What the? Anyway, hit the like button, hit the subscribe button, join me on Discord. One more day till the end of the year. Stay good, stay healthy, to good mental health. Hope you're having a great week, and hope everyone had a good next year. I'll see you later. Bye bye. I have to press the button.